let's assume you encounter this kind of question in your next WAEC or NECO exam. How do you solve this kind of question? I'm going to use two different ways to solve this question, and we are going to arrive at the same answer. So follow me carefully. The question says a given mass of gas occupied 150 cm cube at 27 degrees Celsius and pressure of 1.013 times 10 raised to power 5 Newton per meter square. Calculate the pressure at which its volume is doubled at the same pressure. Now let's quickly write out our parameters. They said a given mass of gas occupied 150 cm cube, which is my volume V1, equals to 150 cm cube at 27 degrees Celsius. That is my T1 equals to what? 27 degrees Celsius. But I'm going to convert this temperature to standard temperature. So by adding 273, giving me 300 Kelvin. Now, and pressure of 1.013 times 10 raised to power 5 Newton per meter square, which is my P1, equals to 1.013 times 10 raised to power 5 Newton per meter square. This value of my pressure, I can also rewrite it to be 1,01300 Newton per meter square. How did I do that? This is 10 raised to power 5, isn't it? Which denotes that it is what? 100,000. Now, if I multiply 1.013 times 100,000, I will have this value, which is 101,300 Newton per meter square. Now they said calculate the temperature. That is my T2, right? My T2 is what? Is unknown. That is what I'm looking for. Calculate the temperature at which its volume is doubled. So my second volume, which is my V2, is twice of my V1. That is 2 times V1, which is equal to what? 2 times 150, and it's giving me 300 cm cube. Now, at the same pressure, so my pressure, this is my second pressure, is the same. That is, it is equal to what? P1. Are we together? And what is my P1? My P1 is, I'm going to use this on 1,01300 Newton per meter square. Now, looking at this question, the first method I'm going to use is that the question says its volume is doubled at the same pressure. That means that the pressure is constant. And if the pressure is constant, it obeys what? It obeys Charles' law. And what is the formula of Charles' law? Formula for Charles' law is V1 over T1 equals to what? V2 over what? T2. Are we together now? Because in Charles' law, pressure remains constant. The volume of a given mass of a gas is directly proportional to its temperature, provided pressure is constant. So my pressure is going to be constant. So I won't use any value of pressure, which is the first method I'm going to show you. So what is my V1? My V1 is 150 divided by my T1 is 300 equals to my V2 is what? Twice of V1, which is also 300. That is 2 times 150. Then my T2 is what I'm looking for. So cross multiplying, I have my 150 T2 equals to 300 times 300. So divide this by 150 and divide this by 150. This cancels out. So I have T2 equals to 300 times 300 divided by 150. I have 600 Kelvin, which is my final answer. Now, this is the first method. Now, let me show you the second method on how to solve it. Now, in this first method, we used our pressure is constant, so we didn't use it. Now, let's use our pressure. But if you are going to use pressure now, we are not going to use Charles' law again. So we are going to use general gas equation. And general gas equation says P1 V1 over T1 equals to P2 V2 over T2. Good. Now I'm looking for my temperature, right? So I make T the subject of the formula by cross multiplying first. So I have my T2, I have my T2 P1 V1, that is this multiplied by this, equals to T1 times this, P2 times V2. So divide this by P1 V1 divide this by P1 V1. So this cancels out. So my T2 equals to T1 P2 V2 divided by P1 V1, right? So now I'm going to impute my value here. Are we together? I'm going to impute my value here. So if I impute my value here, I will have what is my T2? My T2 equals to T1. What is T1? T1 is 300 multiplied by, what is my P2? My P2 is 101300 times what is my V2? My V2 is 300 all divided by P1. P1 is 101300 times V1 is 150. All right, so if I should calculate this, I have 300 times 101300 multiplied by 300 divided by 101 300 times 150. That is giving me 600. So my T2 equals to 600 Kelvin, which is my final answer. You could see that this answer gives me the same answer I got by using Charles' law. So these are two different ways you can solve this kind of question whenever you see it.